Today we're going to be talking about long division, and we're going to be using this thousands block as an example. So if you weren't here for its construction, what we did is we took these cylinder pieces and we stacked them up until we had 10 in a stack. Then we took these stacks of 10 and we started putting them together in groups of 10 until we had one of these frames. And then we took 10 of these frames and we put them together to make a block of 1,000. So that's where this 1,000 block comes from. It's 10 groups of 10 groups of 10. And we want to talk about what happens if I want to take that 1,000 and I want to divide it. So we're going to divide it into 6 different groups. That'll be 1, 2, 3, 4, 5, 6. Each of these gray plates is going to be a group that we divided into. And I'm going to show you the slowest possible way to do it, which is actually how you would have to do it if you didn't have math. So when I want to take this giant block and split it into 6 groups, I got to start tearing it apart. So I'm going to break open this group of 100. It's going to be messy. There we go. And what I want to do is, one cylinder at a time, start putting one cylinder in the first group, and then one cylinder in the second group, and then one cylinder in the third group, one cylinder in the fourth group, one cylinder in the fifth group, and one cylinder in the sixth group. Now, if you have a little mathematician inside your brain that's already telling me that this is the slow way to do it, I love that. Keep that mathematician there. We're going to talk about why it's slow, but I want to point out why the long division algorithm is so genius. And so to do that, we're going to start by doing it the slowest way possible, and then start to look at shortcuts. So I'm going to keep going through the stack, and just one can at a time, putting a can in each group, and that way I'm sure the groups are always even, because if one group gets a cylinder, then all the groups get a cylinder. So all the groups will get a second cylinder. And then all the groups will get a third cylinder. Then a fourth cylinder. A fifth. A sixth. A seventh. An eighth. A ninth. And a 10th. And then at this point, I stop and I scratch my head and I think, why am I so crazy? Each of these just got a whole group of 10, but I counted them one at a time. I should have just grabbed a whole group of 10 and just given them all a whole group of 10. So that's what I'm going to do now. They've all got one group of 10, so let me just give them all a second group of 10. Second group of 10 for the first group. Second group of 10 for the second group. Second group of 10 for the third group. Second group of 10 for the fourth group. And then I have to break into another stack of 100. And then I'll grab a second group of 10 for the fifth group. And a second group of 10 for the sixth group. So now I've thought of a much faster way to do it. If I do this in groups of 10, then I don't have to count every single cylinder. I could just count whole stacks of cylinders. Which sounds genius, except I hope that there's another mathematician telling you, oh, this is not the fastest way to do it. Which is true. Again, I'm going to keep showing you this slow way because I think it's going to help you understand why we do long division the way we do it. So I'm going to keep going with groups of 10, making sure I divide them evenly between all 6 of my groups. So third group of 10 for everybody. Then a fourth group of 10 for every group. A fifth group of 10 for everyone. A sixth. A seventh. An eighth. A ninth. A 10th. And then right here, I need to face palm. I have 10 groups of 10 in each group. These groups of 100 that I've been breaking up, I could have just put whole groups in each of these stacks. In fact, if I had to go back to my thousands block, I wouldn't break up these groups of 100 at all. I would take a whole group of 100 and put it in the first group. Then I'd take a whole group of 100 and put it in the second group. And I would divide them evenly, but I would do it with the biggest groups I could possibly start with so that it went faster. So in one step right away, I could see that all 6 of my groups each get 100. Now, at this point, I don't have 6 more groups of 100 that I can split up. So now I do have to break open a group of 100. But I'm not going to go back to giving each group 1 cylinder at a time because I have bigger groups than that. I can give each group 10 cylinders at a time. And that's the whole idea behind long division. You never break up a group of 100 unless there's not enough to divide evenly. And you never break up a group of 10 unless there's not enough to divide evenly. In fact, if you can imagine a world where I had not just one block of 1,000, but dozens of groups of 1,000. Well, if I have enough groups of 1,000 that I can move whole thousands together and still make it even, then that's what I would do. And that's the genius of long division. With long division, you only split up groups if you have to. You find the biggest place value group that doesn't need to be split up. So now that we've seen what it looks like using our thousands block, let's go ahead and use some numbers and do some examples of it.